Hello everyone, my name is Manvith.
I'm Sanjit, and today we're going to be talking about how galaxies are made.
This will be our first video in Unit 2, and this unit will talk about stars, galaxy, and black holes in the Astronomy 101 course. So let's get started. Now, one of the leading theories on how galaxies are made is a top-down theory. So what this theory says is that dark matter clumped together, which then caused hydrogen and helium gas to clump around the dark matter, and when there was enough mass, the cloud could collapse on itself, which started thermonuclear fusion, which made the first stars. These first groups of stars and their associated dark matter clustered together, and those clusters clustered together, which formed the first galaxies. These galaxies were very dim, and they could have been blown out by the star's supernova, and so a second round of clustering may have been needed to form the first galaxies. The clusters of stars, gas, and dark matter compressed on itself, which over time formed a disk because of the spin of all the matter. The stars are made during and after this process can change the shape of the galaxy. The shape of the galaxy is determined by where stars are made and the shape of the cloud of the matter. The size of the galaxy can also change through collisions with other galaxies. Our Milky Way galaxy is a spiral galaxy, and it formed in a spiral shape because stars closer to the center of the galaxy orbited the galaxy faster than stars from the away from the center of the Milky Way galaxy, which caused the spiral shape of the Milky Way galaxy to form. Now, another theory in which galaxies form is the bottom up theory. This theory states that there were lumps of matter that made the galaxies we now know in the same process. But with this theory, most early galaxies were smaller spiral galaxies, which merged together to make elliptical galaxies, which merged even more to make giant elliptical galaxies, which we have seen in the middle of hotspots for galaxy mergers to happen. Merging galaxies are very often as galaxies are very often galaxies have a strong gravitational pull, and they're pretty much everywhere in the universe. Now Sandra will be talking about the different types of galaxies.
So, there are many different types of galaxies, and one is the spiral galaxy. In spiral galaxies, gravity and spin move stars and matter into a spiral shape on a disk, with closer stars orbiting faster than for ones further away from the middle. These spiral stars and matter only occur on disk-shaped galaxies, and they also occur this way due to the disk differentially rotating, as in the matter moves at different speeds related to the distance to the center.
Now,
Next,
a theory which says how spiral galaxies is formed is called the density wave theory. The density wave theory is what caused the spiral galaxy to form. Basically, what the density wave theory is when individual stars pass in and out of the spiral's arm. It's kind of spiral's arm. This is kind of like when you're stuck in a traffic jam and you move in and out of it. The center of the traffic jam is still dense, with cars just as the arms of the spiral galaxies are dense. As as it does, it creates density waves. These density waves basically form ripples in a pond. Since our galaxy is rotating, these ripples basically create spirals, which cause a spiral galaxy to form. Scientists still don't know what causes density waves. One theory is that the bars that many spiral galaxies have, Baird spiral galaxies, for example, create ripples in the galactic plane that set off density waves. But the problem is for a bar to form, there has to be density waves, and scientists don't know where those come from, and not every spiral galaxy has a bar at the center. Another theory is that satellite galaxies could cause spirals because they tug the galaxy from the outside, but not every spiral galaxy has a satellite galaxy. Now, Sanjay will be talking about the different types of spiral galaxies.
first up, we have barred spiral galaxies. These galaxies are created when a spiral galaxy's orbit breaks down and deviates from a circular pattern, and instead turns into a bar of sorts. It is also thought that this barring process occurs due to a density wave from the center of the galaxy, as Mon previously mentioned, and this disrupts the spiral process. It does this by affecting the orbit of closer stars, slowing them down with enough waves and time, and eventually makes the spiral into a bar shape. Next up, we have the intermediate spiral galaxies. These galaxies are created when a spiral galaxy starts turning into a barred version, but stops midway through, causing it to be intermediate compared to intermediate from the spiral and barred spiral stages. It's not well known why the process stops midway, but that's how much information we have on it. Next up, we have the elliptical galaxy, and elliptical galaxies have a smooth and elliptical shape. They do not have as much structure as spiral galaxies, as they're similar to the irregular galaxies in that respect. The most popular theory for these galaxies is that they are the cause of two galaxies merging and not going into spiral shape. Lenticular galaxies, on the other hand, are basically spiral galaxies with no arms, since they have a disk and a bulge in the middle of the galaxy. The characteristics of a spiral galaxy without its arms, basically. They're also alike to the elliptical galaxies because they have a tiny amount of star formation, and most of their population consists of older stars. There are many theories on how these galaxies may have formed. One states that they are really old spiral galaxies, which made them lose their arms gradually. Another says that they might have been formed by the merging of two spiral galaxies. Irregular galaxies are different from the other types of galaxies because they have no common shape. They can look like a potato or just any random object or a random shape of stars. The theories that try to explain the formation of these galaxies postulate that they may have formed through the galaxy collisions, removing some of their defined structures. These collisions with completely different galaxies result in these types of galaxies having different types of stars, such as young and old stars. Next up, we're talking about the active galaxies. Seyfert galaxies. Seyfert galaxies are very common active galaxies. They look like spiral galaxies, but they have really low energies and radioluminosities. They emit a lot of infrared radiation and a bit of X-ray radiation. There are two types of these galaxies, type 1 and type 2. Type 1s have a faster accretion disks, and type 2 have slower accretion disks. The difference in the speed might be due to the different angles that we look at them through. Quasars are another type of active galaxies, and they're the most luminous type of active galaxies. These galaxies have particle jets of huge power, and they're believed to be episodic, which means that they repeat their behaviors like a sinusoidal function. These are extremely important galaxies because they help us learn more about the black holes and evolution of galaxies. Another type of active galaxy is a blazar. Blazars are basically just quasars that are oriented towards the Earth.
Now we'll
Now,
be talking about miscellaneous galaxies. The first type of miscellaneous galaxy is a starburst galaxy. A starburst galaxy is a galaxy with high star formation rate compared to other galaxies. For example, the Milky Way galaxy has a star formation rate of 3 solar masses per year. Starburst galaxies, on the other hand, have star formation rates of to 100 solar masses per year. One solar mass is equal to the weight of our sun. So, there are a lot of stars being formed in starburst galaxies. Because the star formation rate is so high, the galaxy will consume its gas reservoir faster on a timescale shorter than the age of the galaxy itself. So the starburst galaxy is a phase of a galaxy's evolution. Most starburst galaxies are formed by a merging of galaxies. Our own galaxy will have a starburst phase when it collides with the Andromeda galaxy in 3 billion years because of all the brand new gas. The next type is called the ultra diffuse galaxy. An ultra diffuse galaxy, also known as a UDG galaxy, is a galaxy with a very low luminosity because of its low star count. These galaxies tend to be very old since they have exhausted most of their star forming gas and tend to have mostly type 2 stars, which are very dim. Some of these galaxies are almost entirely made up of dark matter, while other galaxies have almost no dark matter. These galaxies are probably were the first galaxies ever to form in the universe. Next up is a ring galaxy. A ring galaxy is a galaxy that has a circle-like appearance. The ring itself has young blue stars, which are very luminous, and at the center of the ring galaxy. At the center of the ring galaxy, it has old stars, and they have very low luminous matter. A ring galaxy is formed in one of two ways. The first is when a bar in a Baird spiral galaxy reaches a super high velocities, which leads to bar instability, which leads to the spiral to spin out. This leads to density and gravitational waves that make the spiral migrate out and to the side to form a ring. This is also because of the dark and baryonic normal matter ferociously orbiting the bar, making it unstable. The other way ring galaxies are formed is when a smaller galaxy goes through the center of the largest spiral galaxy. This causes bar instability, which makes the spiral turn into a spring, and the other galaxy will push the center out of the larger galaxy, which makes a ring. The next type of miscellaneous galaxy is an interacting galaxy. An interacting galaxy is when two or more galaxies merge, or when a satellite galaxy affects the arms of a spiral galaxy. The Milky Way galaxy will become an interacting galaxy when the Andromeda and Milky Way galaxy collide. A dwarf galaxy is a developing galaxy. A satellite galaxy is when a galaxy orbits another bigger galaxy. The Milky Way has 59 satellite galaxies. A star cluster is basically a large group of stars that are held together by each other's gravity. There are two distinguishable types of star clusters: globular star clusters and open clusters. Open clusters are confined to the galactic plane and are almost always found in spiral arms. They are usually young, which are up to a few tens of millions of years old, but there are few rare clusters, going up to a few billion years old. These usually have few hundreds of stars and usually are around 30 light years across. They can also be pushed away by other objects. Globular clusters, on the other hand, have up to several million stars in the same area as open clusters, most of which are in the halo of stars of each galaxy, and also have type 2 stars. Each galaxy has different amounts of globular clusters. There are also intermediate types of clusters, which means it is a mix of globular and open clusters. Now, Sanjay will be talking about the general characteristics of a galaxy.
Each galaxy has a halo of stars surrounding it, which mostly consists of two types of stars that are super old. They're formed when the Milky Way galaxy was forming. And each galaxy also has a supermassive black hole at the center of it. And all of these galaxies have solar systems, star, dust, gas, etc. Next up, Mon will be going over galaxy anatomy.
A galaxy is a huge collection of gas, dust, and billions of stars and their solar system, all held together by gravity. The structure of a galaxy can be viewed as consisting of 6 separate parts: a nucleus, a central bulge, a disk, both the thin and thick disk, spiral arms, a spherical component, and a massive halo. Some of these components blend into each other. The nucleus is the central region of a galaxy where the most massive and luminous stars are located. It may also contain a supermassive black hole that influences the dynamics of surrounding gas and stars. The central bulge slash nuclear bulge slash galactic bulge is a spherical or ellipsoidal region of stars that surrounds the nucleus. It contains mostly old stars that have low metallicity, the abundance of elements heavier than hydrogen and helium. Next, the disk is a flattened structure that extends from the central bulge to the outer edge of the galaxy. It contains both gas and stars and may have different thicknesses depending on the age and metallicity of the stars. The disk is where most star formation occurs in the spiral galaxies. The thin disk is narrower and contains dust, gas, and stars. It is the main non-center density of matter in spiral and S0 types of galaxies. The thin disk contributes about 85% of stars in the galactic plane and 95% of the total disk stars. The thick disk, on the other hand, is broader and entirely stellar. In contrast with the gas-rich thin disk, the thick disk is composed almost exclusively of older stars and is supposed to dominate the stellar number density between 1 and 5 kiloparsecs above the galactic plane. The spiral arms are the regions of higher density and brightness in the disk that have spiral and logarithmic shape. They are formed by density waves that compress the gas and trigger star formation. The spiral arms are young, hot, metal-rich stars that give them the blue color. There are three parts to a halo: a stellar halo slash inner halo slash diffuse halo, a galactic corona, a massive halo slash outer halo slash dark matter halo. This this the component is a diffuse halo of stars, inner slash stellar halo, that surrounds the disk and the bulge. It contains mostly old low metallicity stars that have high velocity of random orbits. Some of these stars belong to globular clusters, which are dense groups of stars that orbit the galactic center. A galactic corona is a distribution of gas extending far away from the center of the galaxy. The massive halo is an invisible region that extends far beyond the visible parts of the galaxy. It contains dark matter, which is a mysterious substance that does not emit or reflect light but has gravity. The dark matter halo provides most of the mass and gravitational pull of the galaxy. Now let's move on to nebulas. A nebula is a big cloud of gas, dust, and plasma in space. These clouds can vary in size and shape and are often illuminated by nearby stars or other energy sources, making them visible from Earth. Nebulas can be classified into several different types based on their composition and origin. First is the emission nebula. These nebula are primarily made of ionized gas that emit lights of various colors. They're often associated with regions of star formation that are commonly known as H2 regions. The famous Orion Nebula is an example of an emission nebula. The next nebula is a reflection nebula. These nebula do not emit their own light, but instead reflect light from nearby stars. They appear bluish because blue light is scattered more efficiently by dust particles in the cloud. The Pleiades star cluster is an example of a reflection nebula. And then comes the dark nebula. These dense clouds of dust and gas that obscure light from stars and other objects behind them. They're also sometimes called absorption nebula, since they can absorb visible light. The horse head nebula is a well-known example of a dark nebula. The planetary nebula then comes in planetary nebula. These nebula are shells of gas and dust ejected by dying stars during their late evolutionary stages. Despite their name, they have nothing to do with planets. The Cat's Eye Nebula is an example of a planetary nebula. The last type of nebula is a supernova remnant. These are nebula formed from the debris of massive stars that exploded in a supernova event. The remnants of the explosion expand into the space, creating a beautiful complex structure. The Crab Nebula is a famous example of a supernova remnant. And there is a neutron star in the Crab Nebula, which I'm currently researching about. Next, Sanjay will be talking about the interstellar clouds.
An interstellar cloud is a general term used to describe any concentration of gas and dust found in the vast spaces between stars in a galaxy. These clouds can vary significantly in size and density. Interstellar clouds play a crucial role in the process of star formation, and when the gas and dust in a cloud become dense enough, gravity begins to pull material together, eventually leading to the birth of new stars. They are found in interstellar medium, and all nebulas are interstellar clouds, but not all clouds are nebulas. There are two primary types of interstellar clouds: molecular clouds and diffuse clouds. First, we're going to be talking about the molecular clouds. These clouds are predominantly composed of molecular hydrogen, H2, and are the coldest and densest types of interstellar clouds. They are the most important sites of ongoing star formation in galaxies. Now, diffuse clouds. These clouds have lower densities and consist of primarily atomic hydrogen, H. They are not as conducive to star formation as molecular clouds, and interstellar clouds are essential for the interstellar clouds are essential for the cycle of stellar life, from birth to death. So, from the birth of stars within them to the eventual return of matter back into space through stellar processes like supernovae. They also serve as the raw material from which future generations of stars and planetary systems will form. Hope you enjoyed the video.
Thank you
Thanks
guys
for
for
watching.
watching. In the next video, we'll be talking about star formation. So excited to show you guys the next video.